For centuries, there's been this mystery flickering right at the edge of our world. A ghostly light that just dances over swamps, bogs, even graveyards. It's something that has haunted travelers and storytellers forever. A light that almost seems to have a mind of its own. Today, we're going to dive deep into the mystery of the will-o'-the-wisp to unravel a ghost story that stretches back through the ages and ends with a really stunning scientific breakthrough. And this Tolkien quote? It's the perfect way to frame what we're doing here. For hundreds of years, the will-o'-the-wisp was kind of dismissed as just folklore, a spooky story. But as we're about to see, buried inside all those old tales was a real physical phenomenon, a truth just waiting for science to finally catch up. Okay, so let's start with the basics. What exactly is a will-o'-the-wisp? Well, for centuries, people traveling at night have described this mysterious, fleeting light that shows up in the absolute darkest of places. I want you to imagine this. You're walking down a lonely path at night, maybe near a marsh, and up ahead, you see this faint, flickering light. It looks like a lantern, so you follow it. But as you get closer, poof, it just darts away. People describe it as a pale blue or greenish ball of light, hovering just a few feet off the ground. And they often call it a cool flame because it gives off no heat and no smoke. It's this elusive, phantom-like behavior that has captivated and terrified people for so long. So, what do people do when they see something they can't explain? Well, we do what we always do. We create stories. And these tales of a tricky, mischievous flame sprung up literally all over the world, as every culture tried to make sense of this mysterious light. And what's really fascinating is just how universal this whole thing was. In Latin, it was called ignis fatuus, which means foolish fire. That name perfectly captures its deceptive nature, right? In Britain, it became the jack-o'-lantern, which is actually the origin of our Halloween tradition. Over in India, the chirbati, or ghost light. The names change, but the experience is shared all across humanity. The way people interpreted this light, though, varied wildly. In England, it was seen as this evil spirit trying to lead travelers off the path to their doom. But then you go to Finland, and that same light might lead you to treasure. In parts of Sweden, they thought it was the restless soul of an unbaptized child. Meanwhile, in Wales, it was called a corpse candle, a terrifying omen of a coming death. So the light itself was a constant, but what it meant was shaped entirely by culture and belief. The key thing to realize here is that this mystery has been with us for a very, very long time. We've got written accounts going all the way back to 1340. By the 1500s, it's being documented in scientific texts. And by 1776, the great Alessandro Volta, the guy who pioneered the electric battery, is already suggesting a scientific explanation. He suspected marsh gas was involved, and he was on the right track. But it would take nearly 250 more years to finally solve the puzzle. So, as science began to slowly replace folklore, a leading theory started to emerge. And for centuries, the best explanation we had was what's known as the swamp gas theory. The main suspect was a gas called methane, and honestly, it fits the profile perfectly. Wetlands are full of decaying stuff, plants, animals, which releases huge amounts of methane gas. And when methane burns in certain conditions, what does it make? A cool blue flame, exactly like the old descriptions of the will-o'-the-wisp. It all seemed to add up, right? You've got ghostly lights appearing over swamps. Swamps produce a flammable gas that burns with a ghostly light. Case closed. Well, not quite. The swamp gas theory had one giant, fatal flaw. And this is where our little scientific detective story gets really, really interesting. It all came down to a single, tiny, missing piece of the puzzle. See, you can fill a whole marsh with methane, but it's not going to do anything until something ignites it. The gas is flammable, for sure, but it isn't self-igniting. It needs a spark, a source of ignition, and that's the problem that stumped scientists for generations. Let's actually put a number on it. To get methane to burn, you have to hit it with a massive amount of energy. Over 100 kilocalories per mole. That's a huge energy barrier to overcome. You need a significant pulse of energy to kickstart that chemical reaction. So what could possibly provide that kind of jolt in a damp, cool marsh at night? So that was the central question. People suggested things like lightning, but the lights would appear on perfectly clear nights. Others proposed weird chemical reactions with other gases, but the evidence was always weak. For decades, the mystery of the spark just stayed unsolved. What in the world was lighting the foolish fire? And then, just recently, a team of scientists had one of those incredible aha moments. It turns out the solution wasn't a giant lightning bolt from the sky, but something infinitely smaller and way more elegant. A truly groundbreaking study, published in the super prestigious journal PNAS, finally provided the missing piece. Researchers figured out what was causing the spark, and it was all happening on a scale that is almost too small to imagine. Okay, so here's how it works, and this is just fantastic. As those methane bubbles rise up from the muck, the study found that bubbles of different sizes can build up opposite electric charges. So, when a tiny positively charged bubble gets close to a tiny negatively charged one, electrons literally leap across the gap. Zap. This creates a microscopic spark, a phenomenon the researchers actually called microlightning. And that tiny, tiny spark is all that's needed to ignite the methane and create that ghostly glow. And here's the crucial conclusion right from the scientists themselves. This mechanism provides the spark internally. Nature has its own matches. You don't need a bolt of lightning from a storm cloud or some rare chemical. The ignition source is built right into the process of bubbles rising through water. The mystery of the spark was finally, officially solved. So we've gone on this incredible journey from haunted tales about mischievous spirits all the way to the elegant physics of microscopic bubbles. But, solving this ancient riddle has implications that go way beyond just explaining a cool ghost story. I mean, this really puts our whole journey into perspective, doesn't it? What was once seen as a spirit's lantern, we now understand is a physical spark. A mystery that was born from our fear of the unknown has transformed into a sense of wonder, born from the physics of the very, very small. We haven't erased the magic. We've just found it in a different place, in the incredible unseen forces that are shaping our world all the time. And the takeaways here are huge. First, we've solved a puzzle that's been around for over 700 years. That's amazing on its own. Second, we've discovered a totally new chemical mechanism, this microlightning, that we didn't even know existed. And that matters because wetlands are a huge source of methane, which is a potent greenhouse gas. Understanding this new way it can ignite could actually help us make our climate models more accurate. And finally, it opens up a really fascinating possibility. Could other mysterious natural lights around the world be caused by this very same hidden process? Which leaves us with this final kind of mind-blowing question. The will-o'-the-wisp was a ghost that haunted our imaginations for centuries. But in the end, it wasn't a spirit, it was a spark. It just makes you wonder, what other phenomena that we see as mysterious, maybe even supernatural, are just waiting for their own scientific aha moment? How many of nature's ghosts are still out there, just waiting to be explained by physics we haven't discovered yet?